Okay, I may have to split this into 2 lessons because I can only do 15-minute increments and I may run out of time. So what we're going to look at today, or on this lesson, is parts of a radical. We're going to start with just reviewing that because what we're going to do with that is simplify radicals. And so you need to know what the terminology is so that when I say the index or the radicand or whatever, you know what I'm talking about. So parts of a radical. If you have anything on the inside, whether it's a number of variables, whatever it is, that part that's in the radical is called your radicand. The thing that's out here, if there's not anything there, that's called your index. This thing is called your index. If there's nothing there, if there's not a number there, it's understood to be 2. Those would be my square roots. Any other thing will be written, if it's a cube root or a 4th root or a 5th root, whatever the case may be. So whatever this number is called your index. It's the number that's on the outside of the radical. The little symbol, that's the part that's your radical symbol. The whole thing with the index, the radicand, and your little radical symbol, that whole thing is your radical. And so we're so used to saying the square root, the square root, the square root, because we have mostly just done square roots, but we're going to look at taking cube roots and 4th roots and 5th roots and so on. We're not going to get too complicated with it, but just so you can understand the process. So what I've done for you right here, for those of us that may or may not remember our perfect squares and our perfect cubes, and I'm pretty sure that you haven't had to learn the things that are raised to the 4th power and the 5th and so on. I made a little table for you here that you can use to help you get started, but do not let this become a crutch because you will not be able to use this on tests or quizzes. But I do have it here for you to do a quick reference until you get comfortable, and you're going to surprise yourself at how you're going to learn these things and remember them. So this first column, if this is my x value and I square it, this first column is all of my perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, and so on. I'm sure that you know these, or at least most of these. You may not know all the way through 20, but you probably know enough. The third column, that's my x cubed. That would be 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. These are my perfect cubes. These are the things that are raised to the 4th power. If I know 2 to the 4th is 16, 3 to the 4th is 81, and so on. Things that are raised to the 5th power and to the 6th power. We will not ever use these gigantic numbers over here. So don't even freak out when you see that. I just did this in an Excel spreadsheet, and it puts all of that in there, and I wasn't going to go through the hassle of taking it back out. But don't freak out when you see that. We're really going to stick with these lower numbers. But this is just here for you to have a quick reference, but it's not for you to develop a crutch so that you depend on it on tests and quizzes. So I'm going to show you 2 ways to simplify radicals, and I know you've already done this. This entire first unit really is review, but we got to knock the dust off of it because some of you haven't had math. Most of you, I guess, haven't had math in a pretty good while because you wasn't in here last semester. So I'm going to show you 2 different ways. I have a preference that I like to use. I'm not going to tell you my preference, but I want to show you 2 ways so you can figure out what's more comfortable for you. I'm going to start with this prime factorization method, and I'm going to give you some steps, and then I'm going to step right over here and show you some examples on the right-hand side of your paper. So the first thing you're going to do is write the prime factorization of the radicand. Remember, that's the thing that's under the radical. So when I say the prime factorization, that means we got to go back and know that our prime numbers. Remember that our prime numbers are things that are only divisible by 1 and itself. And so my prime numbers, just to get you started, to help you remember that, is 2. 3 is a prime number. 4 is not because it's divisible by 1, 2, and 4. 5 is a prime number. 7 is a prime number. My next one is 11, and then 13, the next one is 17, and then 19, and so on. It's just numbers that you can only divide by itself and 1. So you're going to write the prime factorization of whatever's under the radicand. The next thing you're going to do is use that index. Remember, that's the number that's out in front, that little tiny subscript out there, to determine. And please pause this if you need to, because I'm writing or talking faster than you are. Pause it and do what you need to do. So you're going to use that index to determine how to group the factors, and then you're going to circle up those groups. I'll show you what I'm talking about in just a second, because that's how we're going to do the simplification part of this. So the next thing you're going to do, the number, or it may be variables, from each group comes out of the radical. You may still have some things left in the radical, and if you do, that's fine. You may not, and if everything comes out, you'll see what I'm talking about in a minute. If everything comes out, the radical goes away. And the last thing you're going to do is just multiply the numbers. I'm going to cut short right here so I don't run out of time. And the variables outside. If whatever goes to the outside, you're going to multiply it all together. And if there's anything inside, you're going to multiply all that stuff together too. So let's do a couple of examples here. So we're going to scoot over to the right-hand side of your paper. And now this paper is going to fold in half, so don't scoot too far over. I'm going to do some prime factorization examples right here. So I'm going to draw a line right here that kind of evens me up. If you can, I can't get everything in one shot, but you can see that I'm just going to draw a line to separate, so I can do prime factorization and examples, and then the other method and examples here. So the first one I'm going to do, I'm going to do something real basic, and you're going to think, dear Lord, why is she doing that? But I'm going to do it anyway. I'm going to do the square root of 36x squared. So prime factorization, I'm going to need a little bit of scratch room, so I'm going to come over here to the side. See if you can see that. And I'm going to break that down into prime numbers. And I always start with 2 because that's my smallest number. So 36 is 2 times 18. And 18 is 2 times 9. And 9 is 3 times 3. So I'm going to break this square root of 36x squared down to 2 times 2 times 3 times 3. And I'm even going to break down my variable to it's x squared, so that's x times x. So I said you're going to use the index, and if there's nothing there, it's understood to be 2, to group these things into groups of 2. If it's an index of 2, then I'm going to group in groups of 2. Groups of 2, groups of 2. When you circle up, every group, you cross it out, and you bring it to the outside. You cross it out, and you bring it to the outside. You cross it out, and you bring it to the outside. And notice there's nothing left inside. So my radical is gone, and I'm just left with 2 times 3 times x, which is 6x. And you already knew that the square root of 36x squared was 6x, but I'm just showing you the process. I wanted to show you on an easy one first. Okay, so now let's do another. I've got the square root of 24 n to the 5th. So I'm going to take 24, I'm going to come over here and do a little bit of scratch work, get my prime factorization. 24 is 2 times 12, and then that's 2 times 6, and then that's 2 times 3, and I'm left with all prime numbers. So now I'm going to rewrite this as 2 times 2 times 2 times 3. 1, 2, 2, okay. So 3 2's in the 3, and then I'm going to break down the n. 1, 2, 3, 4, 5. Oh, that was cute. You see what I did there? So now I'm going to circle up That's an understood 2, so I'm going to circle up groups of 2. There's a group of 2. There's a group of 2. Every group of 2, I cross it out and bring that number just one time to the outside. I got a pair of ends, take it out. A pair of ends, take it out. And I'm left with a 2, a 3, and an n. So here's what I've got. 2n squared, because n times n is n squared. And that's going to be times the square root of 2 times 3, which is 6, and a single n. Back this up and watch it again if you need to. Last example that I'm going to do like this is I'm going to do a bigger number. I'm going to do the 6th root of 448, x to the 7, y to the 7. I'm running out of room right here, so I'm going to break my prime factorization down right here on this side. So me personally, I start with 2, because if I'm getting all of my prime numbers, I want to start with the smallest one. So that's going to be 2 times 224, and you can use your calculator to do this part. And then that's going to be 2 times 112, and that's going to be 2 times 56, and that's 2 times 28, and that's 2 times 14, and that's 2 times 7, and I've broken it down so that everything here is a prime number. So I'm going to rewrite this. So I've got 1, 2, 3, 4, 5, 6 2's. So 1, 2, 3, 4, 5, 6, and a 7. 1, 2, 3, 4, 5, 6, and a 7. 1, 2, 3, 4, 5, 6, and a 7. I've got 7 x's and 7 y's. 1, 2, 3, 4, 5, 6, 7. Okay. So I want groups of 6 because I'm taking the 6th root. So there's a group of 6. There is a group of 6. And there is a group of 6. So I've got a group of 2's comes out. A group of x's comes out. A group of y's comes out. That leaves me with the 6th root of 7x, y. And that's the prime factorization method. So the next lesson you're going to watch is going to be just recognizing your perfect squares, cubes, and so on. Feel free to back up and rewatch, pause, slow down, whatever you need to do.